Hello, everyone. Welcome to session 10, the Data Science Mentor Program. My name is Pablo. I am the host, founder, and convener of this session. Now, this is a continuation of our last session where we're looking at color bars, right? And so today, I promised in the last session that we were going to look at color bars in a different way, right? So just so we're going to get started, and as we proceed, I am going to I'm going to explain a bunch of things as we proceed. Now, as usual, I'll get started with it. As usual, the first thing I want to do is to import matplotlib. Again, color bars are super interesting. It's typically a way you customize the colors you use in your visuals, right? The way you customize the colors are important, and how to get do it is typically important. But what I'm going to do today, I'm just going to show some examples and write some example code. But the idea is for you to pick up how you would typically look at certain types of data and then customize colors to reflect the intuition or to reflect the idea you're sharing, the insights and all that you're trying to share to your audience, or you need your audience to understand. I don't know if I have said this often in this session, but your ability to understand problems is super important as a data scientist. Not just writing code, right? Writing code is a bit of the technical thing that happens under the hood, but understanding the problem, understanding how to, the moving parts of every problem with respect to the problems it needs to solve, and the edge cases that may come up. So let's start off. Like I said, in every session, I act like this is the first time I'm doing a session, and I'll almost always import the libraries for it. So we would import matplotlib, or import matplotlib .pyplot as PLT. Additionally, we're going to import numpy as np. Also, we're going to put the magic command where I will put our inline matplotlib inline, right? For static, just stating that we're using arrow. Oh, okay. This should be here, right? Now, the simplest color bar can be created using a plt.colorbar function, right? So let's just let's call this the simplest color bar. Again, today is going to be I'm just going to do a lot of stuff that just helps you understand how you could make use of this. Now we're going to create again, use matplotlib, use numpy to create generate data. So I call this x np.linspace and 0 to 10, and then how many elements? We can do 800 elements. And then we can, of course, have y. And when we have y, we can now say np.sign, which is x, and also have that multiplied by np.cosine. Again, the idea is the data typically that we're creating. It's typically not, it's just the data. The assumption is that these data points were collected randomly, right? So so here the cosine here is going to be on a newer axis here. So rather y would have it created sort of like we have a new axis with np.new axis. Now, this is the data we have, and then we can go on to use one of this here to now create what we want. So I can do plt.imshow. So with imshow, we get to display data as an image on a 2D platform, so to speak, right? So here, I'm just going to put Y in here. Then I say plt.colorbar, which is the function for us to get out of what we're looking for. Then go on to say plt.show. Now you can see what we have here. So let me see. plt.figure. Here I'm going to have fig size, and I'll put a tuple of say 6 by 4, so that it's somewhat bigger than what it is. So you can see what we have here, right? So you can see that we have a color bar. You can see with the different the data points we have, you can see them 800, right? And we're now visualizing this color bar, and by default I've just thrown this in. Now this is basically what it looks like without customization. Now what if I wanted to customize it? Now if I wanted to customize the data, I'll take another step here, and I'll say plt dot imshow. Now what we're working with is Y, and then I can now use CMap. Now CMap, just to put it in perspective, you can see CMap over here, right? Then what CMap does is it's a color map instance, or the registered color map name, so which will just map our data to. And it's simple. We can just basically use this. You can see blues, and then I'll say plt.show. Right, you can now see that we have blue here. That I can use different colors. Let me see, where did we even get our color maps here? So I show this because this is what we use. I can use greens here. So plt.greens. You can see that typically if we wanted it to look big, we just basically get this guy over here. Right, you can see it. So this typically a very simple way to customize it. Now, the next conversation I know you probably ask is, how do we choose color maps? So what I'm going to do, I'm going to drop a bunch of like links and articles on how you could choose this, on how there are different articles. I'll drop them in the Telegram channel, in our Telegram channel, which is where we typically have our conversations, right? But generally there are different ways we could look at getting colors, or rather choosing color maps. We could think of, so let me call this choosing color maps. Now we could think of choosing color maps in many ways. First off, we could think of qualitative color maps, right? So qualitative color maps are like, look, we're trying to visualize maybe qualitative data. So we may not really think of we may not think of a lot around it, but we'll just have a mix of color with no particular sequence, right? So there are many ways. And now to put it in perspective, you see that we have different color maps that exist. You can see these different ones here. You can see the diverging ones. Look at them. It's in this color map setup here. You can see that there are different needs. For instance, sequential plots, right? If you're plotting stuff that is sequential, you want to use that. But what we wanted to talk about is the qualitative ones. So you can see with qualitative color maps, right? You know, there are different things we could use, right? Um, and these are some of the things we typically want to use in a qualitative. There's no particular sequence, right? But maybe because there are different categories, right? So stuff like this. So just again, if you want to make sense of it, jump on this. I'll drop this in the link. And I'll drop this link in the Telegram channel, so you can look at it. I'll drop it there. But yeah, typically what you would want to use now, just so I read out a few things here. It said now qualitative color maps. The qualitative color maps are not aimed at being perceptual maps, but looking at the lightness parameter can verify that for us. So if you look, you can see that they sort of like increase or decrease depending on what it is you're trying to achieve, right? So you can use any of this if you're trying to build like sort of like a color map that enables you to visualize stuff, right? So let's look at we have set one, right? So let me see. Let me see if I can use one here. Set one. Look at that. You can see the qualitative color maps and the way these things are broken down. And you can see that they just feel like they're categories or stuff you're trying to look at. So, but this is basically choosing color maps. Now, the one thing we talked about choosing color maps is that we can look at one, you know, qualitative. You can look at choosing it as what am I saying? How you're going to choose the maps. You can think of it as one qualitative color maps. It's like the intuition for picking it, right? Now, again, remember, it is a qualitative color map is not an ideal stuff. It's not ideally used to visualize quantitative data. So always remember that. Two, and again, you can always refer to the documentation. Another way to look at it, you can think about divergent color maps. As a matter of fact, let me bring as I talk about them. So I'll show them. So let me bring this guy over here. Let me put a copy here. And so look at that. So we have the qualitative color maps. I mean, documentation is highly important here. So let me make this look good. Yes. Now, the next thing we want to think about is divergent color maps, right? Here you would have like two distinct colors which show positive and negative, right? So here we have divergent color maps, right? So let me put this here so they look good. Uh-oh. Now with divergent color maps, let's come over here. Then we'll go over here to divergent. Now you can see with divergent color maps, right? You can see sort of like it's like it's showing us a move from one status to another. That's why they often contain like two distinct colors, right? And so it could be black, it could be bad or good, it could be positive or negative. So we should always have this when we're thinking about creating stuff. So again, here is it's this usually contains two colors, two distinct colors. Right, and there are examples of these color maps here. You can see the way they are. So you can see the different mapping. Now, again, it would be ideal. I'll come over here again and copy this, and then we'll make a change just to look at what this looks like. Then we come over here. This is basically a very transparent activity. So you can see that I can copy this color here. You can see, or you can take any of this color. Right, so let me see. Okay, let me take Berlin. And over here, I come and change this guy here. Why is it taking so long? What's that? Berlin is not a valid for CMAP. Really? Are you sure? Okay, we can just pick up one of these guys. Did I miss out on something? Or it has been... Oh, hold on. Do you see that capital? Did I write that as capital letter? Ooh, no. Okay. I'm just curious on why. Okay, let me take this. Because it's already stated there. Because I mean, I'm surprised. Look at that. We have P. All right, so let me just pick up this guy, just for us to explain divergent color maps. So this shouldn't be a problem. Okay, so again, let me run this one more time because we run it over and over again, right? So you can see that here we have divergent color maps. You can see almost like two colors, right? You can see almost like two colors showing two distinct situations. So again, I want us to always think about what we are typically picking up before we do that. If we're going to visualize data that's trying to show contrast between two situations, maybe you typically want to use this kind of, you have to use, it's ideal, it's intuitive to use this kind of color mapping. Then the last one I'll talk about, even though that's not the last, is because there are others. You can see over here that we have sequential 1, 2. So I'm basically just going to talk about sequential here. So over here, you can see what sequential is, right? So you can see that we use it like we always use the typical ones here. So here, I'm going to basically okay, so with sequentials, they have continuous sequence of colors. So here, continuous sequence of colors. Right, again, come over here and use this as our base. And then I'll change this to plasma. You can see the continuous sequence of colors. It feels like it's like a heat map, right? There are different color variations. There's inferno, there's magma, there's, we typically use this a lot in the last time. So we see that. So again, you want to know the kind of you want to know the kind of colors you want to use, right? And how they how they are, right? There are codes we can use that will just, we can basically say this is the mapping we want to use. Inside of it, we'll just put in, we'll create like a sequence of, we can create a sequence of colors. We show you the grayscale of the color. We show you that. I'll just use one of it, and then we can do a visual of it, and you just see how that turns out, right? But it's you would see that in the code book, right? But it's just a sense of showing you the kind of color we have and what the grayscale looks like. So I'll just use one from the quantitative style. I already had that created before we started today's session. Then I'll just visualize it, right? So so let me start off just this one before we now go to the main stuff we have for today. So again, I'll just basically import the map plot, the segmented color maps. This is it. Then the next thing I'm going to do, I'm going to create colors that will bring out first of the color, and then we'll bring out the color itself, the gray color, and typically the color and the grayscale of it. So would have a definition of this. I'm going to share that just a bit. So this is the first part of it. Now it's important to state that in my initial where I read this from, right? A lot of things had changed. Like for in here, at the point they were using there were deprecated codes for it, which made it really interesting to kind of find out how to get this. But again, stuff like, for instance, codes like this, right? You would see something like cm.getMap, which has been deprecated but still works, and you would get like some warning from it. But again, you can basically jump on this. And then again, I'm going to create a function that would get us you see the color side of what we're looking at. So this is the two things here. If I run this code, it should work. So that means I can view the colored map, and then with the colored map, I can also have a gray style to it. So which means I basically call the grayscale mapping of it inside this code here. And then we now went on to plots, right? You can see we have a 6x2 plot, and then we're going to have in the first, because again, remember when we talked about the different ways for principles of creating code, we spoke about the MATLAB style and the object-oriented part of it. So we're visualizing basically two of them here, right? Which will have the grayscale and we'll have the color. So the best way for us to do it is to basically call the function view color map. Now, if we say view color map, I can go over to the color coding here, and let me see. I can look at qualitative. We can look at qualitative here, right? Let me see. Let me use paired. Look at what paired looks like. So I'll copy paired, and then with that we can put in paired here, and we can use plt.show, and it will show us the color and the grayscale. It should do that. So you can see that. So this is what paired looks like, the color and the grayscale. We can use this and do a bunch of things. We can look at different colors we have, and they'll show us the grayscale and all. So this is what it is. And when I share this, you would have access to this, so you can see, gives you idea of what the different color coding looks like. So that's basically that. I guess that's what we're going to talk about in this aspect before we go on to say, okay, let us visualize. Let's just do a visualization using data on color coding, right? So this will be important. Now, the first thing we're going to do is we're going to load images, and we're going to use this image to talk about different visuals. Now, the image we're going to be using is an SK-Lens data set. When we get into machine learning, we're going to use the MNIST MNIST data set. The MNIST data set is used in machine learning, to explain different machine learning techniques, and it is images or digits, right? So we're going to use this. Now we're going to also do this, and just for visual, just to talk about what we're doing, the larger perspective is when we're going to be doing machine learning, we're going to do something called dimensionality reduction, where we use certain techniques to reduce the dimensions of the data but you don't lose the essence. And there are different techniques for doing that. There's principal component analysis. There's dimensionality. There is principal components analysis. There are a bunch of it, but today there's something called manifold. It's like the manifold technique, so to speak. The manifold technique is a way of reducing. It's a way of visualizing your data in 2D, but using certain techniques to ensure that you basically head to the look at your data in a way that makes a lot of sense. But the reality is that's not the conversation we're about. The conversation is how we can use different color mapping just to look at data. That's typically what we're talking about, but not genuinely. Not typically about the machine learning, the unsupervised machine learning technique. No. Now, so that's what we're going to be doing. So we are going to use the manifold learning, that's what it's called, to reduce the dimensionality of the data for keeping the relationships of interest. But that's not the main issue. I mentioned that what we just want to see is how we can visualize with different color maps. And that's the primary objective, not the machine learning technique or the unsupervised machine learning technique. Now, first, I am going to visualize the machine learning data, the data or digits data. That's what I'm going to do. So here I would, we're going to look at the data we're working. So here is the digits data. Now to do that, again, like I mentioned, the first thing I'll do is to call our library, is to use our library. So we'll call this sklearn.manifold. Look at that. And from that, we're going to import isomap. I hope this is it. Yes, isomap. Now, what we're going to do is we are now going to put isomap, and we're going to put isomap, and we're going to say maybe we're typically looking for maybe because isomap is typically saying we have data, but this data has different neighbors, so to speak, right? And but we're going to define this data with colors just to put perspective to it, right? So we type ISO. Now we're going to call on isomap here. So you can see the isomap, which is it's an embedding for nonlinear dimensionality reduction. Now, the first thing we want to do is we have n_component, right? And it's ideal for us to talk about it, or even though this is beyond the scope of what we're doing, but we're going to look at the number of neighbors we want to work with. We're going to look at a number of coordinates for a manifold. We just say 2. It doesn't really matter what we have. We can also talk about the number of the neighbors. If we leave it by default, it's going to give us 5. We're going to have 5, right? Should we, or we can bring out different color coding. So we can, let's say 10, right? And then we now go on to the data. We've gone to look at our data. No, have we? Have we introduced our data? No, I haven't introduced our data. What am I doing? I think I jumped the gun and went straight off to the other thing. No, you see? Apologies, guys. I was looking at something different. So I should have showed you guys the data. This should be the digits data. So this would load the digits data. So we load the digits data. And that's where I should have used the skLens data set. Apologies, guys. I was from the data I have out there, I must have jumped it. Okay, so from sklen.datasets, right, we're going to import load digits. This is it. Second, we're now going to have the digits itself. We call this digits, and then what we have, we're going to have load digits, and then we would, because the digits is from 0 to 10, we can just reduce it and say maybe we just want to look at specific number, maybe 5, let's say 0 to 5. To do that, this load digits, we will say n number of classes we're going to have here, n underscore class is going to be equal to 6. Right. So I think this is it. We already have this. So this is what it looks like. So it's going to be a lot of data here, but just so you know, so there's a lot, but that's not the main issue here. So let's just have that closed up. Now, what we can do is that we want to visualize, these images. This image will have. So what we do is we can typically enumerate through it and visualize it so it makes some sense. So the first thing we want to do is we want to set up our objects that we're going to use to visualize it. And remember, because we are setting up objects, we're going to be using the object-oriented style of visualizing. So we first go fig and ax, and we say plt dot subplots, right? That's what we're going to do. We're going to now have our subplot. We're going to have 8 by 8, and then we will have our fig size, which is really important. We're going to have our fig size, and which is a tuple of how large we want it. So let's do 6 by 6. Next, we're going to now say for I, comma, and then in our axis, we're going to say we're going to enumerate. So we're going to enumerate. We're going to say the axis is going to be flat. So, and then we'll go on to say this is what we want to visualize. What do we want to visualize? We want to say axis dot in show, which is what we have used before to visualize data. Then what are we visualizing? We're visualizing digits, right? So we're going to visualize digits, and we're going to look at the images of the digits, right? So we have our I here, which is what we have, and we're going to say CMap. Now, you see, with CMap, what we're now asking for is colors. Now, because they are digits, what we want to visualize, right, is we want to visualize them in a way that, you know, that we have two colors that makes it easy for us to see. So we use binary. And if we come over here to binary, in sequential, there's binary, did we show binary? Maybe, yes, look at that, binary. One of this is it, binary, it's good. Yeah, something like this, black and white. So that's what we want to do the visuals in. Then we're going to say axis.set. Here we are going to talk about our x-ticks, which is the difference. We're going to look at our x-axis and the y-axis and the different. When we say ticks, what exists inside. So we're typically going to leave it based on the way the digits come out, right? So we have and then we have y ticks equals this. Now if I run this, then this should come. Now we already have it here, so I can say plt.show. So it should show us our digits here. So you can see we have, if you look really well, we have 0, 1, 2, 3, 4, 5, 0, 1. Right? So all that's 0 to 5. That's typically what we have here. So that's what our visuals are that we have going on. Now we already have that. Now we want to project. What we want to now do is, this is what we wanted to have I wanted to talk about here, that I messed up everything. So we want to visualize these digits in 2 dimensions, right? We want to visualize these digits in 2 dimensions. And if we visualize these digits, we would basically, we're sort of like reducing our data, right? But visualizing it, right? And that's where we're using isomap, which makes it easy for what the manifold learning, which is dimensionality reduction. And again, that's not what we're typically well, that's not the scope of what we're doing, but just to show you what it looks like when we visualize them in terms of colors, right? With color mapping, because color mapping is the important aspect. So here we need to project the digits. We need to project the digits into 2 dimensions, right? And so that's what I use the manifold stuff here. Then we can now type this as projection. Now in projection here, we're going to say iso.fit_transform, which is basically going to train the data so as to put it in 2 dimensions. So that's what we do. Did I write this correctly? iso.fit_transform. So what we're going to have here is our digits.data. Now we've done that. So it's trained this. Now we need to now visualize our data. Now it has trained this stuff, and now we already have data in here, but we now need to visualize our data. And we now, because what we have is different, we have it in 2, but we need to look at the different color digits from 1 to 5. We'll now use colors to map them. And because they are sequential, right, we will go to, we'll look at what are we going to use. Let's come to this one over here. So we're going to look at different ways. What do we use? We use any of these colors to get a sense of its, yeah. No, we're not going to use this ones. Like we can use any of them. Yeah, we'll just use one of these colors here, especially from here. We can use one of this just to have a sense of what it looks like. So we use for sequencing. Now we need to now plot plot, we need to plot projections, which is this. Now to plot, we're going to use pt.scatter. What are we plotting? We're plotting projections, right? And we're going to plot the first aspect of the data, like the first column itself, or the first dimension. And we're going to have projection, and we're going to plot the second dimension, right? So with plt.scatter, we could do a bunch of things. We're going to also look at the line width, right? We're going to look at the line width. And if you look over here, line width, where is line width? Yes, which is the width of the marker's edges, right? So we're going to look at that. So we have LW equals 0.1. Then we are now going to use C. Again, you can see that it's like a color array. So we're going to say, we're going to have the digit.target. Now the digit.target are the features that are 0 to 1, our 0 to 5, which is what we typically started working on here. This is what we have here. So we're going to say the digits dot target. Then we're going to now have CMAP, which is our color. So we're going to say plt dot color maps dot get CMAP. Right, this is where we're now going to get a color we're going to use. So we've used this a lot of the time, but we're going to use it again. It's not hard to use this. Let me see. Yes. Then we'll use this as our color map here. Then we have plt.colorbar, right? And then we're going to have, we're going to look at our ticks. And we have range. So it's going to, we have a range of 6, which is basically 5. We're going to have a label. Our label is going to be our digits. That's what we're going to call it, our digits, right? That's going to be our label. And have this closed. Then we're going to have plt dot color limits, right? So basically set color limits for what we have, and our color limit, we're going to go from 0.5 to 5.5. Look, I have to tell you, even when I was learning this before sharing, you can see that there are different color limits you can set, right? So we have the minimum to a maximum, right? So just to use it as color scaling, and we talked about it in the last time. The last time you see it on the side, you see the color set up on the side, and then finally we now say plt dot show, right? And then we put this. Oh my word! I thought that we had. I thought we set it. No. plt dot fig. plt dot fig. Dot figure. And then we can use our fig size. I'm going to use our fig size here, and then we'll have 6 by 6, so that it shows us what was not closed. Okay, right. So you can now see what we have here. Really looks good. So you now see what color mapping looks like, right? Now this color mapping is typically used because you're trying to understand. We broke digits into different colors, and now with color mapping you can see the different dimensions of the numbers we have, right? You can see them moving from here over to here, right? And you can see how we can now see them in 2 dimensions. But the idea is, hold on, let me put this again. Let's make this 5 by 5. It seems to be too much, right? So you can now see that what we are now looking at is, I want us to see this. Yes, you can now see how this looks, right? So you can now see what color maps are about when you're looking at data, when you're trying to visualize, maybe data in terms of dimensions, and how the color maps helps. And because we're dealing with numbers, it's ideal we use like a sequential. We use this classes of colors that are sequential, right? Of course, you can see we can use any other one here. I can choose to use magma, and again, you can see how that looks. Now, the question is, what if we now decide, you know what, let us use one that is for qualitative, right? And just to know what that looks like. So you can see, we now choose, let's use pastel 1. And just see what the intuition will look like. So we run this. Now you can see when we now use pastel 1, I mean, right? It's sort of like we can typically see it, but it does not give that zing like it would be if we had used, the sequential type. Again, let's look at another color map class, which is we didn't talk about cyclic. This let's look at which other one, divergent, right? So you can see the diverse. Let's look at divergent. Get me? I sort of feel like divergent could tell some story. Let's look at seismic and see how that is. But you can see that it's like it's two distinct colors, right? So if we only put 2 distinct colors here, can we get an intuition of what we have going on? It sort of like felt like it worked, right? Yeah, because maybe for the fact that with seismic we're looking at distinct color maps, right? And it's able to look at the 2 dimensions. But again, is there any information that is lost because are there any information that is lost because we are using something that is supposed to help us, is supposed to give us like two divergent colors where we're saying maybe positive or negative or the opposite ends of a color map, right? But if it sort of like gave us a sense of something that works, right? Or maybe let's look at, we could possibly look at this. Let's look at twilight. Let's see what twilight looks like. Again, it's a cyclical color map. Just to look at, again, the intuition that exists when we look at the different color map classes that have different color map intuition. Look at that. Giving us different things and showing us data in different ways, right? But at the end of the day, I think that visualizing the data in using the sequential type sort of like makes it look better. Look at this, miscellaneous, right? So visualizing it with sequential colors like this very one. Let's use Inferno, which gives us a grade from, like it's going from 0 to 1 or from 0 to 100, right? So let's use Inferno, which is this, and see if it will give us that zing that has been missing since we started it the first time. And so you can see that you can see that there's a thing about this sequential type. You can see the way it is there's a lot of graduation that happens. So I think generally using color maps that fit what we are trying to achieve in terms of visualizing data and the intuition in the data we're talking about. If, let's say, we're looking at data, maybe visualizing the quality, the lack of access of a certain gender to jobs stuff, we can want to split it into two, the colors into two, and maybe there's maybe a legend describing maybe percentage of access or lack of access. Then you can see that the distinct or the diverging colors will basically help tell us a bunch of things. Again, just like a recap, we've been looking at in our ninth session, right? In our ninth session, we did an introduction. In the ninth session, in our ninth session, we did over here, we did an introduction to color maps. And then we are now following up with looking at the different types of how we will choose color maps and all. That's why we call this part 2. And in the part 2, we're customizing it, but not just customizing to see what we have. We're trying to customize now, say, with different color maps, what does that actually mean? When we customize, we're customizing to be intuitive, right? And my hope is that as we proceed, we're going to start seeing, if we're going to think about how to visualize data, then we typically be looking at different color setups to tell us stories, and to understand our different color maps with their different intuition helps us make sense of it. If we're choosing for qualitative data, we're choosing for, we're choosing for divergent data, which gives us like 2 color distinctions, or we're looking for sequences that show us different aspects of it. And we now went on to show you that with there's this function, these 2 functions here, these 2 functions help us to visualize the different color setup we have. For instance, I know that I just pasted Inferno. So if I put Inferno, you see how Inferno looks from this, which is really cool, especially if you've got to make a decision on the type of color you want to use, and see what it looks like in black and white, and see what it looks like in the colored side of things. Then we went on to look at data, very popular data used for machine learning, which is, it's the MNIST data set. And it's a digits data set basically, but I mean, it has the MNIST relationship. And we imported it from sklearn data repository. And then we went on to look at numbers from 0 to 5. And because you can see that there are in this dimensions that you can see, an 8 by 8 dimension, so to speak, we now decided to use a technique, a dimensionality reduction technique, to reduce it into 2 dimensions without losing its essence, and then visualize it using a sequential class of color maps. And then went on to now see what it looks like if we used other classes like qualitative color maps. And we can see that the Zing, the intuition basically comes up when we use sequential class of color maps. So yeah, so that's typically what we have today. I said it was going to be somewhat technical. I hope it wasn't. I hope if you watch this again, it's typically simple for you to understand how we can use it in sort of like a technical fashion to visualize colors. I hope it also gives you a sense of how you can use basic visualization to do stuff. Right. So if you have questions, if you're watching it a live session, please drop question in the comment section, or you can basically indicate by asking a question. And if you're watching a recorded session, please check out, just go to the Telegram channel and drop your question. Hello, Grace.
Yes, I'm really confused. I see where you use the word n_neighbors, and I'm wondering what that's about.
Okay, so
you have 10, and then I'm familiar with the word pt2. so far. I see where you made use of im show, and I'm wondering why.
Okay.
So for the same thing for that box where you have those figures, where you have some numbers inside, yes.
Okay. So good question, great question. So what I mentioned when we started was, this is beyond the scope of what we're doing, but typically what this is their digits. In machine learning, when one very popular data set for explaining or illustrating machine learning concepts is there's a digit data set. It's often called the MNIST data set, which contains images of handwritten numbers from 1 to 10, or rather 0 to 9. Now, that is what we used here. Now, and we loaded the data, and then, but when you have the data, you typically want to visualize it because it's an image, right? So with that image, it is easy for you to use, with images, easy for you to use ImShow to visualize your images, right? So if you have data that is an image and you want to visualize it, you can use ImShow. If you have colors, images, so they are almost always images, so use ImShow to visualize them. So that's what the ImShow is there. Now, for us to illustrate using different classes of color maps, we had to come into the world of dimensionality reduction. It's an unsupervised machine learning technique. And that's why, again, I mentioned that it is beyond the scope of what we're doing at this point, but it was important to use something we're going to do in future to explain color maps. And so that's what I did here. Now, for a technique, an algorithm, or a package for using manifold learning is isomap. And one thing it does is that it takes the data, right, and tries to break the data into dimensions, and you can indicate the number of connections you want, sort of, for lack of a better term, close connections you want the data to have in terms of similarity, right? So I now decided to put 10 neighbors, right? It sort of like tries to break them in as much neighbors as it can, right? And in the end, we're able to see like 1, 2, 3, 4, 5, 6, 7. I'm certain there are other colors that might be different, but it broke them down into neighbors. You can see in this two-dimensional space, that's what it tried to do, right? So that's generally what this aspect of this is for. Again, I apologize if it is bringing something too close before it's time, but I just needed to use this as an illustration of our colors itself, because this is the primary aspect of what we're doing, right? So yeah.
Okay.
Also, I just hope that you can use this as an opportunity to see if you want to visualize data. First off, we set up the figure and the size. We have our scatter plots. We can say, look, there's a way we want our color to look based on the data we have. And then we can say our color limit is going to be from something to something. You can see our color limit here. And we can go on to now say pt2.show, because right now it's no longer an image, right? It's now like a visual, right? Unlike here where it's an image. And so you can see ImShow and pt2.show now takes a different, there are different responsibilities now come into place, right? So that's basically what that is.
Okay, sir.
Again, watch the video again, right? And then you just get to see what the intuition looked like. Right. I think that should be the end of this session.